Okay, guys, so just a quick review of quadratic models. Remember, quadratic models were when you actually put the applications into quadratics. All right, so, pretty much it's taking the the problem and seeing, okay, based off of what it's asking, what process are we using from quadratics to solve these problems. Now, these slides are from when we first went over quadratic models back in your junior year. And if you notice, like in this problem, it says a farmer wishes to fence off the maximum area possible to make a rectangular field. She has 150 meters of fencing. One side of the land borders a canal. Find the maximum area of the field. And remember, since we are going to be dealing with quadratics here, the maximum area would be that y-coordinate of the vertex. Because basically, you're going to have a quadratic, okay, and you're trying to determine the maximum area. Well, the maximum on this quadratic is right there at the top, at the vertex, and more specifically, it's going to be the y-coordinate. The x-coordinate will tell us what dimension the field would have to be in order to produce the maximum area. So the x would represent the dimension that would give us the maximum area, and the y is the actual maximum area. And so in the problems like this, we had to figure out, okay, what information did we have? Well, we had 150 meters of fencing. Well, fencing is basically perimeter. And we had to set up an equation for perimeter, which is what you see here, P equals 2W plus L. We plugged in what we knew, which was 150 meters for the perimeter. And the reason why we had 2W plus 1L only was because the other length was bordering the canal, and we wouldn't put fencing around the canal. Now, because we're trying to produce our maximum area, the formula for a rectangle is the length times width. You couldn't have two different variables. You only had to have one variable here. So we solved the perimeter equation for L, and then we plugged it in to get 150 minus 2W times W, and then we distribute that, and that's how we got our quadratic. Okay? And so in problems like this where you actually have to create the equation yourself, you have to look, okay, what do I have? And what am I looking for? Do I have the perimeter and I'm looking for the area? Do I have the area and I'm looking for the perimeter? Do I have volume and I'm looking for surface area? Do I have, just different, you got to read the problem and see exactly what you have. And realize that if they don't give you the quadratic, you're going to have to create it, and you have to use what is given to you in the problem to do as such. Sometimes they might give you an equation like this one, talking about a rocket. And then from there, it's pretty much, okay, what's the question asking? Find the height of the rocket above the ground after 10 seconds. Well, 10 seconds represents the time, so you plug in 10 for t. Find the maximum height. Again, maximum height would represent the y-coordinate of the vertex. Find the length of the time the rocket's in the air. So basically, how long is the rocket before the height reaches back to 0? So you have to set it equal to 0 and solve for t, okay, because you're looking for your time. So just depending on the problem, you pretty much just have to decipher exactly what it is that is asking you to find. Again, here's another one. They give you the equation. Maximum weekly profit, maximum. Anytime you see that word maximum or minimum, it's going to be associated with the vertex. Okay, and more specifically, if it asks you what is the maximum weekly profit, that means it's looking for the y-coordinate. If it asks you how long it took to reach the maximum profit, then you're looking for the x-coordinate of the vertex. Find the loss for a week's holiday period where no units are sold, 0 units. Well, that means that you will plug in 0 for U, because U represents the number of units sold. And to break even is basically when your function equals 0, where basically you haven't made a profit, but you haven't lost anything either. Okay. Do realize that profit is equal to your income minus your cost. So if you ever had to set up a profit equation, profit equals income minus your cost. All right. And then these are just a few other examples of, creating the equation yourself and breaking it down. But basically, if you're going to be looking at the application part, you're going to basically be looking at for potentially 4 items. They are You could be looking for the maximum or the minimum of something, maximum area, minimum cost, any of that, which basically means the y coordinate of the vertex. The maximum or minimum time or the amount of a product that the company makes, that would be the x coordinate. So if they ask for like the maximum time or the time it takes to reach the maximum, or the minimum the how long it would take to produce the minimum cost or something, you're basically looking for the x coordinate of the vertex. Sometimes you have to plug in 0 for y, and that basically means you're going to be looking for your x-intercept. Something like that would be how long would it take for the rocket to hit the ground. You're looking for the x-intercepts there. Anything like that. And then, of course, the problems where you just plug in numbers for x, and usually x or t represent your time. And so then you just plug in to get your y value. So you're gonna be doing one of those four things. You're really not gonna do anything outside of that. But this is just kind of refreshing your memory about it. If you actually want to go back and look at the video that had these problems on it, all you gotta do is just go to my page, look up quadratic models, or just quadratics, applications of quadratics. I can't remember what the exact title is, but just go and you can rewatch that video from Eugene to refresh your memory. All right.